record on this. Now, we saw last week, we actually worked through some very basic code related to the Titanic data set. The Titanic data set is a very common starting point for people who want to explore machine learning, AI, data science, etc. The good news here, additionally, is that because it's so common, you can easily find resources to help you better understand what other people are doing. Now, we could work through Kaggle and look at other people's notebooks, but I just wanted to point out, hey, I just Googled really quick to find an example, and I found one. So let me share my screen and we'll have a peek. So here we see Towards Data Science, a very common website for people to post their exploration of particular machine learning, data science, etc. Content. And in this case, someone, Jason Chong. So here it says a comprehensive beginner's guide to Kaggle and the Titanic survival prediction competition. So I'm going to copy and paste this into our chat. It helps if I have the chat open. So if you can, go ahead and bring this up on in your own browser. And let's have a look. Let's see what we can learn. Notice it gives an anticipated reading time of 13 minutes. I suspect will take a little bit longer. But the intention is, hey, let's see what we can learn from other people who've actually worked with the same data set. First and foremost, we've already talked about Kaggle, and it does show up in the sense that, hey, we can actually use Kaggle for a lot of our work. We didn't in this particular case, we use Colaboratory, but Kaggle comes up frequently. And this individual gives a very nice write-up through their process. First things first, they actually start with, hey, what is machine learning? And I think that's nice for beginners. If you're going to work through a data set like the Titanic, it makes sense to start at the foundation. So I appreciate this writer's approach in this sense. Jason's an associate data analyst at Quantum. So obviously someone who has a professional background related to this. And I won't read all this content, but let's scroll down to the next section. Notice supervised versus unsupervised learning. We could read it here, but without looking for a second, who remembers what's essentially the difference between supervised and unsupervised learning? And maybe you're just reading it and putting it in the chat. That's fine too. But who remembers this breakdown? Anyone? James, Nick, Tyler?
It's supervised just where like the data kind of learns from itself almost.
That's a good start here, James. So the data, we actually have labeled data. We have data that we can point to and say, we have the answer for a bunch of this stuff. We want you to then be able to predict the answer using these labels. So you were on the right track there, James. And supervised is where we're starting because, well, often I think it's very intuitive to start this way. We might do an unsupervised task for our next notebook, actually, just to see an example of unsupervised too. Now, I think it's well written. Again, this is a classification problem that we're working through with the Titanic. Did you survive or didn't you survive? And so let's work down to the next section. Now, as Kaggle works in terms of competitions, I want to caution you though, there's something we brought it up briefly, but we have to be aware of it. Let me see here. Let me use notebook as a tabula rasa, so to speak. Here's my blank slate, and the blue's fine. Let's say we have this data set, and oh, whoops, I'm actually going to do this differently. I'm actually going to share my iPad. I think we can do it better. One sec. I'm going to share my screen on my iPad because I can also draw better. As long as I can find my stuff. I apologize for the delay. I've only got so much time. Can't find my writing utensil. Let's go back to the screen here and I'll just make a quick point. I won't get fancy. Sorry. That's how it goes. When you want to find something on a messy desk, you can't. I'll just draw it off to the side here. Let's say we have this data set. And let's say the data set looks like this. That's fine. Now, if I were in a competition and I just wanted to get the absolute best score, what could I do? I could actually build. It doesn't take much to create a function that runs through all the points. This would be great for the competition, but this would be terrible as a model. Why? What's your intuition on this? Why do we not want to just build some type of model that runs exactly through all these points?
Because you're just building an equation to give you a known outcome.
Yeah, Nick, it would just be, it's only going to help with this specific data, and it's not really a good model per se. We're just actually giving a specific result, just as Nick pointed out. This is called overfitting. When we actually have something like this and we just keep refining our model until it just runs through the exact points we have, that might be great for the competition, but it's terrible as a model. We typically want our models to show authentic predictive capabilities. We want them to generalize to populations. And you want to avoid overfitting. Now, underfitting is also an issue. Let's say we have this, and let's say this is the general. I apologize for when you're drawing with a mouse, it's not so easy. Let's say I see this particular set of data and I figure I'm gonna use linear regression and I'm just, that's what's fit. That's a terrible line actually in terms of actually fitting it. I should move it up a little bit. Let's say it's somewhere in there. This would be an example in terms of models. When I see the curve to this data, there is a subtle curve here, isn't there? If I change my color, you can see the data actually has this sort of trend to it, doesn't it? If I actually just use linear regression here, I would be concerned that I'm underfitting the data, that I'm not actually capturing the general pattern that's present. Does that make sense to everyone here? So the idea is we have to fight these two urges to either overfit it and just have it run through. Again, I could build a function where it just goes exactly through all the points. That's terrible. Or I can underfit it by essentially choosing, in this case, the wrong model. We have to watch both. When you're in a competition, the temptation is going to be to overfit. I've found people on Kaggle who have super, like fantastically good accuracy, but it should never, this isn't really a machine learning exercise at that point. It's more a mathematical equation generation competition. Who can make the equation that matches this data perfectly? We want our models to generalize to the population. The Titanic is good for learning some basic processes, but the way you want to think about leveraging this most of the time is that we have some type of data that we're working with up front. Here's what we have to train with. Here's our data initially. We're going to work with that. And the idea is there is more and more data coming our way. We're not done. We are going to apply this model to this inflow of new data, and it has to generalize. We don't want to overfit, but at the same time, we don't want to underfit. We have to find a balance. Overfitting, technically speaking, what you're thinking about here is there's certain noise in the data, right? Like it doesn't fit a perfect pattern. There's noise, there's measuring error. There are things that make the data noisy. We don't want our model to capture noise. We want our model to capture authentic measurements of the data, and the generalization should apply to the greater population. Does this make sense to everyone? In the chat, just put a Y. Like if this is generally making sense, you can either overfit and you're just finding every little nook and cranny of your data set and matching it, which is not good. Or you can underfit and you're really missing some very basic features of the data. We want to find a balance. And the idea is we start out with this initial amount of data, but there is a constant influx of new data coming our way, and we want it to generalize. That's typically when you talk about big data, what are the qualities of big data? Has anyone taken a course where we've talked about big data? It's okay if you haven't. There's one letter that we focus on when we're trying to remember big data. So We want the 3 V's. People have actually augmented this and come up with others too, but we want the 3 V's to essentially define what big data is typically. And so let's see if I can remember them. One is volume. So, just vast amounts of data. Another is velocity. So that is to say, you're not just getting large amounts of data, it is coming fast. And finally, variety. The data is not some clean, if you've worked with SQL, you have these well mapped out tables, everything you've actually created a table where everything has a very neatly defined column and you know exactly what to expect in the table. And we are not dealing with this type of data typically. There is great variety. And so some whole classes of data might be missing several features that you'd like to use, but others might have many additional features. We're dealing with the 3 V's. And so when referencing big data. And so because of this, I want you to be aware of the idea that we don't want to overfit and we don't want to underfit when we're applying machine learning principles. It'll be tempting when you're looking at the competition stuff to want to overfit and say, look at my accuracy is better than this other person. Don't. Actually try and create a model you think would actually be beneficial if there was more data coming your way. You want to capture the data, but not the noise. You want to capture the patterns. So now let's work through more of what this individual covers here. And we only have 10 minutes, but we can get through a fair amount of this. Notice, again, working through the basics we did last training set, talks about setting up a training set here. Excellent. We have to create a model, but then we also want to see how well it works. So we create 2 sets of data. We create a training set and we create a test set. We'll be talking about more in the future, like a validation set and other things, but right now we just stick with the basics. We create 2 sets. One is to create the model, build our classifier. In this case, we used a decision tree. And then once we've built it, we say, how well does it work on data it hasn't seen yet? Now, notice there are some fields that they look a little bit different than what we saw. For instance, we didn't have the embarked. I purposely chose a version of this data set that was quite clean. Again, I didn't want us to have to deal with a lot of the data mangling up front. We are going to be doing that. Here, notice exploratory data analysis. Jason in this article brings up the idea that one of our first steps should be, hey, take a peek around the data. What do you see? We did that, if you remember last time. In ours, it was very quick. We had limited time, but we made some quick figures that actually help us explore the data. Here we see there's a meaningful difference in terms of predicting whether you survived or not, just related to sex. So exploratory data analysis, what they're referring to here, just looking around the data, what do you see? This is something we didn't do last time. What do you think this is? What would you call this? Anyone have a guess in the chat? What's it look like for plan detective? This is a correlation matrix. And it's set up in a way where the colors actually denote, it's like a heat matrix. It lets you see where the highest or lowest correlations are. It gives us a quick hint. Where could we look to actually help determine which features we want to include in our classifier? What will we leverage to make a prediction? And notice they point out here, insightfully, look, in this case, fair is correlated at 0.26. That's we haven't covered correlation much at this point, or actually, I don't think we've really covered it at all. It's just a relationship between two variables, and at 0.26 is pretty big. So fair does a really good job. There's a relationship there of some type that could be leveraged. Now, I forgot to, let me take my drawings off. There we go. You don't need that circle to stay on the screen. Also, other notes, this graph shows passengers of young ages have a higher survival probability. That makes sense. And then data pre-processing, what we've talked about. I purposely chose a version of this data set that wasn't missing values, and we didn't have to do a lot of work to it. We did one thing. We made one particular change. We actually changed sex from a string variable to numeric, yes or no, essentially 0 or 1. That's the only change we had to do. But depending on what we want to use in the future for our classifier, for our models, we may have to adjust the scale so they're all the same. So for instance, we're almost out of time. So let me here. Let's see here. If we're dealing with, let's say we're talking about real estate, actually, just for something easier. Notice number of rooms. So I'm going to put NR for number of rooms in a house. Let's say number of rooms has a range of 0. Let's say, it's a studio, doesn't count as a room. I don't know. To 20. I don't know. Some people have mansions. I can't relate to that. We live in a dinky little house with a big family. So this is a range for number of rooms. That's supposed to be a colon. Nice colon there. That range 0 to 20 works nice in decision trees. We could also use a decision tree here, but let's say prices. I'm gonna just put $. And that ranges from 11,000 to, we'll say 1 million for now. And you see the trend. We could go on. Each one's going to have a different scale. Now, because of the way decision trees work, we can just use a decision tree, and we don't really have to worry about that as much. We'll talk about that more. But other types of models are very sensitive to these different scales. They won't work as well if we have a 0 to 20, 11,000 to 1 million. We would need to standardize these in ways where they are similar. We could put them on a scale of 0 to 1. And so number of rooms would be put in terms of 0 to 1. And price could also be put in terms of 0 to 1. And if we did that, we could use a greater selection of possible models. So I just point out, when we're talking about data transformations, feature engineering, things like this, there is a lot that we have to consider. I chose decision trees last time because, one, it's very common to use this as a learning tool early on, but two, they play nicely with various ranges. We didn't have to do a lot of prep work. Not so for others. Now notice down here, we're almost done. So model training, they list several different models that could be used. One of them is what we used. So we use the decision tree right here, but there are several others that could be used, and we're going to explore many of these. Not all of these, but many of them. Now, let me clear my drawings. Get this. Notice this individual, Jason Chong, actually performed what's called cross-validation. That's another technique we'll learn about. But what we need to see here is the takeaway was you can use different models, and the way that they configured their models, there were differences in terms of how good how well they predicted the category of did not survive versus survive in this data set. Notice decision tree right here, very respectable. When you think about it, a 0.77 accuracy, as we'll talk about more what that actually means in the future, but that's really good. We hardly did any work. We used very little code when you think about it, and we have a pretty fantastic predictor for this classification problem. It's incredible to me to see where we are in terms of the tools we have and what we can very quickly do. Now, in this case, hyperparameter tuning also talks about some other things we'll be doing in the future. But essentially, think about it this way. Sometimes we have to determine how we want our model to learn. And we adjust hyperparameters to do that. So my point here is this. You can actually Google around, and let me clear my drawings here, and you can find several other posts. I mean, several makes it, that's completely diminishing how many you can actually find. You can find many different posts that actually work through this. And so Titanic, pandas, because we're using pandas and scikit-learn for much of what we're doing. I just did this. We can actually see that there are many that just pop right here. Here's someone who works through this. Now this one requires a subscription, but there are many people. If you go to GitHub, same type of thing. You see there are videos that actually walk through this. My encouragement to you is when we start with the Titanic data set, there's also one you'll hear about the iris data set, flowers, making predictions about which type of genus the flowers are representing. These public data sets make it easy to learn from other people. And we're at a stage where we've got one notebook. Several of you, this is a shorter recording today because we actually worked through with the LCC group to make sure everyone was caught up and all of the notebooks worked for the people who were here in the session. And then we started recording when we talked through this new content. But the hope is you can explore this on your own during the week and have fun doing it and realize there are great resources out there. Now, I want to finish up with some stuff just very briefly, just take a couple minutes. But before I do that, does anyone here have any questions related to what we talked about so far today? I just wanted to give a little bit more overview because we're going to be learning about a lot of new things. And I think sometimes it helps just to get a high level view of where we're going, which for us will be a little bit more work in the data and preparing our data for other types of analyses. So I don't see any questions. Now, one thing I'd asked about before, but I really want you to try and do this week, because next week, this is my intention. Have any of you looked around for a data set that interests you? So those LCC club members here today, any of you looking around for a data set that we can explore? So Nick has looked, hasn't found me a like yet, no problem. James, not yet. I encourage you this week, have a peek around and see. Remember, Kaggle has lots of data sets, whether you're into maybe your fantasy football league, people are talking smack and you want to use machine learning to make better predictions so you can win the league this year, stuff like this. Yes, we can get that data. It's up on Kaggle. NFL.com makes some of it available now too. Yeah, Tyler, UEFA Champions League. Yes. All of these things are options. Or maybe you have your own type of data that you're collecting. What I like to do early on, though, when you're working with data sets where it's just one little data set and then you're and it's just, let's say working with that data set, coming up with a training set and then actually testing it. I want to encourage you to start playing around with data sets where new data is coming in all the time. And what this naturally does, you don't even have to think about it. You start to catch yourself prior to overfitting. You start to think, hey, I'm overfitting at this point because this is not going to help me for next week's fantasy league. Every game's new, every game's different. When you're dealing with data sets where there's an influx of information, it's in your best interest. It behooves you to actually try and avoid underfit or overfitting. And so I appreciate that aspect. So I put that out there. Everyone, please, this week, try and find a data set that interests you. And the hope is next week, if you bring it, we'll talk through people's data sets and what we can even do some steps related to what would we do first with this particular data set. We'll just in real time make some decisions, explore the data, see what we can find. And James registering for Kaggle right now. Excellent, James. That's great news.
I have an aside question.
Yeah, sure.
Hopefully it doesn't sidetrack. I posted a screen cap.
Okay.
Because I ran a correlation matrix on our data set. How do I get it to show all of my columns? Because it made it smaller.
I'll tell you what.
Did it not do it right? No, there it goes.
Let's stop the recording now. And we'll be finished for this week. And then I'll just quick with you, Nick. I'll let you share your screen and we can see what's going on. Does that sound good? Let me see here. So I'll stop sharing. I'll see the rest of you who watch the recording next week. Sorry, it's a shorter recording, but it worked out well for our club, for people to be able to get caught up in our notebook related to the Titanic. And we just covered some extra things towards the end here. So see everyone next week. And I'm going to stop sharing. And we will stop the recording.